Hello students, welcome to Anne's classes. Let's do chapter 3 integers exercise 3C. Exercise 3C, mental maths, and this is found on page 56. So in mental maths, the first question is fill in the blanks. So the first one, negative 36 plus 8. Now since it's mental maths, we have to do it in our minds as much as possible. So here we are adding a negative number and a positive number. That means signs are different. When signs are different, we put the sign of the bigger number and we subtract. So 36 minus 8. Whenever signs are different, we subtract, and the sign that we put should be the sign of the bigger number. So here we have 36 minus 8. Let's subtract this. So this is 2 and 16. 16 minus 8 is 8. 2 is here. So we have 28. So here negative 28 is the answer. So to do it faster, what do we say? Signs are different. So put the sign of the bigger number and subtract. Now here it is subtraction. Now when we do subtraction the regular way, this is how we do, isn't it? Negative 36 minus 8, and then we say negative 36. We change subtraction to addition. We write the additive inverse of 8, which is negative 8, and then now it's become addition. So we say signs are the same, put the same sign and add. 36 plus 8 is 44. So this is when more steps are required from us, and when we need to do it in detail. But in mental math, we have to do it in a single step. So all you have to do is look at the two signs. Signs are the same. Put the same sign and add. 36 plus 8 is 44. So we get negative 44. So this is when you are required to do more steps and more marks are allocated. Whereas here, this is mental math, so we do it in a single step. Now look at this one, negative 46 minus negative 6. Again, let me work this out the proper way and then I'll show you the shorter way of doing it. So if we have to do it with more marks allocated, so it will be negative 46 minus negative 6. So the next step will be negative 46. Subtraction changes to addition. We write the additive inverse of 6, negative 6, which is 6. So now this has become addition. And signs are different, so we put the sign of the bigger number and we subtract. So we have minus 46, we have the negative sign, then 46 minus 6 is 40. So our answer here is negative 40. So whenever you are required to show more steps, depending on the marks, you show all these steps and get your answer. Again, this is mental math. Now how do we do this in a shorter way without doing all these steps? Now here can you see a negative subtraction sign and a negative sign here. So minus into minus, this will be minus into minus makes it plus. So when it is plus, it just becomes negative 46 plus 6. Can you see that? Now the signs are different. We put the sign the bigger number and we subtract. So whenever you see a minus sign before a bracket, remember you have to multiply or change the sign. Simply change the sign. So here negative sign here. So minus into minus is plus. That's how we got plus 6. Okay, so this is when you're expected to work out more steps. This is when you're given as mental math. Now here we have a similar one just like this. So we write 53 as it is, and here we have a negative sign and minus. So minus into minus is plus. So that is plus 10. 53 plus 10 is 63. This is how we do it quickly for mental math. Now, if we have to do it the other way, how do we do it? We say 53 minus negative 10. Then we say 53 plus the additive inverse of minus 10, which is plus 10. 53 plus 10 is 63. So all these steps are required when there are more marks allocated. But in mental math, you need to do it quickly and get your answer. So here we have one more sum like that. So we have 0 minus negative 13. So minus into minus is plus. So this becomes 0 plus 13. How much is 0 plus 13? 13. So can you see how we are doing it faster in mental math? Let me do it the normal way and show you. So 0 minus negative 13. So this becomes 0, minus changes to plus, and then we say write the additive inverse of negative 13, which is plus 13, just 13. So 0 plus 13 is 13. So all you have to do is do it in a single step like this and get your answer. Now here we have 9 plus 1 minus 61. So here let's work out the numbers with the same sign, that is 9 plus 1 is 10. 10 minus 61. Here also, can you see signs are different? So put the sign of the bigger number and subtract 61 minus 10 is 51. Question 2. Write T for true and F for false statements. Question 1. 0 is a positive integer. Now, as we know, there are positive integers and negative integers, but 0 is neither positive nor negative. So this statement which says that 0 is a positive integer is a false statement. So we write the letter F to say that this is a false statement. Second one, 10 degrees Celsius below freezing point can be expressed as negative 10 degrees Celsius. That's correct. Below freezing point. So it becomes negative. So negative 10 degrees Celsius, this statement is true. Third one, negative of minus negative 15, that is minus negative 15 is equal to plus 15. That is minus into minus, we just learned in the previous question. When you multiply minus into minus, it becomes plus. So two negatives make a positive. So this statement is also true. The predecessor of negative 9 is negative 10. Remember, predecessor is the number that comes before. So you can think of your number line. Think of your number line and see, then you will know that the number that comes before negative 9 will be negative 10. So this statement is also true. Now, if we have to work this out, okay, so let's work it out. Now, since it's mental math, you need to work it out in your head and get your answer. But otherwise, let's work this out. Predecessor means minus 1. So, negative 9 minus 1. So, how do we work this out? Negative 9 minus changes to positive addition. 1, we write the additive inverse of 1, which becomes negative 1. So, this is negative 9 plus negative 1. Signs are the same. So, we put the same sign and we add 9 plus 1 is 10, negative 10. So, the predecessor of negative 9 is negative 10. So, this statement is true. Question 5. On subtracting negative 40 from 40, we get 80. Now let's just put that into one step. So we have 40. From this, if we subtract negative 40, what do we get? So let's not work out all the steps because it's mental math. Instead, let's straight away do it in one step. So this is 40 and minus into minus is plus. So this becomes 40 plus 40. What do we get? We get 80. So this statement which says that on subtracting negative 40 from 40 we get 80. This statement is also true. Question 6. Successor of negative 1 is 0. So remember, successor is the number that comes after. So think of your number line. What is the number that comes after negative 1? It is 0, isn't it? So this statement is true. Now if you want to check your answer, successor means you add 1. So negative 1 plus 1. So let's see how much that is. So here we have negative 1 and here we have positive 1. So negative 1 plus positive 1 is always 0. So whenever you have a negative of a number and a positive of the same number, when you add it up, you get 0. Okay, so here we have the absolute value of negative 15 plus 10 is negative 5. Let's check if that's correct. Now the absolute value of any integer will be positive. So this will just be 15. 15 plus 10 is 25. It is not negative 5. So this statement is false. Now we come to assertion reason questions. What are assertion reason questions? Now in such questions you will have two statements. One is an assertion and the other is a reason. Now assertion is a statement. It is a statement that will express a particular point, a particular statement, a particular fact. So that is a statement. Now what is the reason? The reason will be an explanation of the statement, or it will be a justification for that statement. Now what we need to do is we need to say whether the assertion is true or false, and if this reason is also true or false and is supporting the assertion or not. So here we have four options. Multiple choice questions, we have four options. In this, both assertion and reason are true and the reason is the correct explanation. That is option 1, where both are true and this reason is the correct explanation for this assertion. Option 2 will be where both the assertion and reason are true, but the reason is not the correct explanation. That is option 2. Now option 3 will be assertion is true but reason is false. Option 4 will be assertion is false and reason is true. Now what we have to do is we have to find the relation between the two statements following the four options given to us. Now let's begin with the assertion. What does the assertion say? The integer which is 2 less than its additive inverse is negative 1. Okay, so let's write that down. So what does assertion A say? The integer, that is negative 1, is 2 less than its additive inverse. So the additive inverse of negative 1 is what we have to write first. What is the additive inverse of negative 1? Positive 1. Now, negative 1 is 2 less than positive 1. How do we know that? Now let's take 1 and minus 2 from this because that's what it says, isn't it? It says minus 1 is 2 less than 1. So 1 minus 2, we have taken this one, minus 2 to show it's less than 1. Now let's work this out. So when we work it out, remember this has a positive sign and there is a negative number, the negative sign there. Signs are different, so we put the sign of the bigger number and we subtract 2 minus 1 is 1. And what have we got here? We have got negative 1 here. So negative 1 is 2 less than 1. We have proved it here because we subtracted 2 from 1 and we got negative 1. So negative 1 is 2 less than its additive inverse. That is what the assertion says, isn't it? That means the assertion A is true. So we have found out that the assertion A is true. Now we have to work on the reason. What does reason R say? It says for an integer A, negative A is its additive inverse. That's true, isn't it? You take any integer. Now this is A. You take 3. What is the additive inverse? Negative 3. That's what it states here, negative 3. You take 17. What is the additive inverse? Negative 17. So this statement that for an integer A, negative A is its additive statement is true. That means the reason R is also true. That means we go for option A. Option A which says both the assertion and the reason are true and reason R is the correct explanation of assertion A. So I hope you understood. So we have two statements here. One is the assertion, the other is the reason, and you will have four options. The first option is always where both are true. Assertion and reason are true as we proved here. The assertion is true, that is this statement is true, and we also proved that the reason is true. Now what about the reason being the explanation for this assertion? Yes, the reason R is the correct explanation of assertion A because it says that for an integer A, negative A is its additive inverse and we have found that out here. Right. Now the second assertion reason question is given to us. Now what is the statement for assertion? It says all whole numbers are integers. So let's take that down. So assertion A says all whole numbers are integers. Now what are whole numbers? All whole numbers are numbers that start from 0. All these are whole numbers and these are all integers. All whole numbers are integers. So assertion A is true. So we can say assertion A is true. Now what does reason R say? Reason R says on the number line all integers on the left of 0 are negative. Let's write that down. So on the number line all integers on the left of 0 are negative. So all of us know what the number line is like and all the integers that are there to the left of 0 are negative. So that is true. All the integers on the number line which are on the left of 0 are negative. So we can say reason R is also true. Assertion is true, reason is true. But is this reason an explanation for this question? This reason says all the integers on the left of 0 are negative. Here it's an entirely different thing. What does it say? All whole numbers are integers. So this is not an explanation for this assertion. Both are true, but reason R is not an explanation of the assertion statement. So here we choose option B. Option B, which says both assertion and reason are true, but the reason is not the correct explanation of the assertion A. So this is how we answer assertion reason questions. There will be two statements. You have to see whether assertion is true, reason is true. If both are true, you have to see whether the reason explains the assertion. Or if both are true, you have to see whether the reason does not have an explanation for the assertion. So accordingly, you have to write whether it is true or not true. We'll stop with that for now, children. In our next video, we will continue with the remaining questions. Thank you, children.